All right, so for the last exercise, the last video finished right with us working on the radius for t, which we were working on a squaring and squaring. So what happens to a square root and a square? They go away. So we have r equals the square root of 3 plus 3. So r is equal to root 6. And that does not simplify. But what we can do is think about where that is on the unit circle. So, well, actually in the coordinate plane. So if we have a root 3 and root 3, that's going to go somewhere out this way because they're both positive. So we can imagine that it's similar to our example where it was 3, 3. And that is an angle of 45. So we could write it as 45 degrees, or we can write it as root 6. What would that be? Pi over 4. Okay, those are the two options for us if we're in radians or in degrees. For this guy over here, that's actually a coordinate on our unit circle. So let's actually figure out where that is. So -2, -1/2, and positive. So that's somewhere up here. I think I remember that that is 2 pi over 3 from our practice. So we can go ahead and figure out what the radius of that is. And hopefully you remember that the radius of the unit circle is 1. So this is 1, 2 pi over 3 to get that coordinate. Remember, the radius is not what we really need to draw. We should be just thinking of the point. But that's how we create it. It's like you're rotating around. And we'll work on this a little bit more. Let's jump into going backwards. Say you're given rectangular coordinates and you're asked to put in, or excuse me, polar coordinates, you're asked to put into rectangular. So very simple. We already know that x equals r cosine theta and y equals r sine theta. Cosine goes with x. If you think of the unit circle when we're talking about x values, cosine is what we think through. And then if we think of sine, that's our y value on the unit circle. So they kind of match up. Let's see what our equation would give us. So let's say we're trying to find 3. 3 is the radius, and this would be the theta. So let's go ahead and write it as 3 cosine 3 pi over 4 and 3 sine 3 pi over 4. Yes, this does require a little bit of work on your part as far as remembering the unit circle. So cosine is 3 pi over 4, where? At negative root 2 over 2. Okay. And then 3 sine at that value is root 2 over 2. So when we simplify, that gives us negative 3 root 2 over 2, 3 root 2 over 2. And that's the rectangular form of that same point. You can do the same thing in degrees. So we would have 20 cosine negative 60 degrees, and we have 20 sine negative 60 degrees. All right, so cosine negative 60, remember, is down this way. So that would be what value? That's similar to what happens when we're around the unit circle and we're at 4 pi over 3. Or excuse me, 5 pi over 3. And that point is 1/2 negative root 3 over 2. So we can say 20, the cosine value of that is 1/2, and then 20 negative root 3 over 2. So our final value is 10 negative 10 root 3. And those are our values. And that's going from polar to rectangular. It's a little bit easier than going the other way. Let's try these rectangular coordinates. Actually, I want you to try this on your own before I show you. So I'm going to pause it. You should pause this video and try these two on your own and check your work. Okay, so we have -2, negative pi, and we have, well, this one you needed to use your calculator for. Sorry to not say that. Calculator for this guy. Oops, calculator. Okay, so for the first one, you should have gotten 2, 0, And for the second one, using your calculator, you would have gotten 2.61 and then negative 3.80. Sorry, I forgot to tell you to use a calculator for the second one. But that is not unit circle value, so you do not have the option to think through that without your calculator's help. All right, so the second objective for today is to plot coordinates on the polar axis, and then also to name polar coordinates in 4 different ways. We're going to continue this in the next video. So we will start up right with this.